I know that. That's why I was going to offer a hand.
Okay, here in this chart here, you see the thermosphere listed as being 80 kilometers and above. 80 kilometers is about 50 miles. The rocket traveled to about 72 miles. So you would assume that you've got the lower, the middle, and the upper. So you would assume it would be in the lower category. So it says nitrogen is 78% of what exists there. Oxygen is at 21%, argon at 0.9, and water vapor at 0. So actual water vapor, meaning H2O, does not exist according to them. But what is it exactly that it does exist there that would make up for the sounds and behaviors of this rocket? The first amateur rocket in history, actually, to make it to this level. Says the temperatures are in the range of negative 95 degrees Celsius, ranging to great fluctuations up to 2,000 degrees positive Celsius. So huge fluctuations in temperatures, high levels of nitrogen, oxygen, and something that makes it seem like there is water there. Now let's take another look at another video on the subjects that we're on. hopefully you gain some opinion there as to what you could decipher as to whether the Earth is flat or the Earth is round. I could give you some opinion on that as to what my thoughts are on it. Let's continue for the moment. Let's think about this a few other ways. Like, we look at the sky and it's blue. We look at the ocean, it's blue. Assuming that you've got a clear sky or a clear ocean. Okay? And the ocean looks blue because the red, orange, and yellow, which travel in long wavelengths, are absorbed more by water than blue is. And really it's the hydrogen that actually is absorbing the red, orange, and yellow. And the blue is actually reflected by the oxygen. So when white light from the sun enters the ocean, it is mostly the blue that gets returned. So I apply this, of course, same reason to the sky, that the reason the sky is blue is because the oxygen that's in the sky is reflecting the blue, and the other gases, such as in our air, which there's plenty of hydrogen in our air, is absorbing the yellow, the orange, and the red, of course. Same thing goes with nitrogen. Nitrogen also will absorb a lot of colors rather than reflecting them. Now, if you remember my chart here that we were looking at about a thermosphere, you recall that the thermosphere is made up of nitrogen, oxygen, and the temperature variations in this area of the thermosphere range from negative 95 degrees Celsius to as much as like 2,000 degrees Fahrenheit. And then just logically thinking about, well, if it gets down to that cold, at the beginning of thermosphere, as you can see here by this chart, it's the end of the mesosphere and the beginning of the thermosphere. And when you're passing through the stratosphere, the temperature rises. As you can see the temperature chart down here, okay? It kind of zigzags backwards and forth. And the coldest area that exists in our atmosphere is right where you pass into the thermosphere. Basically, right where that rocket was toward the end of its path, going up. As you can see here, this is 50 miles right here. Okay, 75 miles. So you got the temperature is the coldest here. So if the temperature is the coldest, that would make me think that there's possible liquefaction of the oxygen in the air, which is, what was it said, 23%, was it? One of the charts that we had up here. 21%. So there's 21% oxygen in that, in the thermosphere. So, and if the temperature is low enough, right there where you're going in, which is the coldest point in our entire atmosphere, that you would have a type of liquid. So then that would lead me to conclude that what we're seeing here is liquid, but it is liquid oxygen and possibly even some liquid nitrogen, or even maybe, well, due to the low concentration of argon, it shouldn't be argon, we should be talking about liquid nitrogen, liquid oxygen, is what we're hearing that sounds like water, which I find very interesting.